Yeah, welcome to this video. Thomas here. I thought it might be a bit too stressful to do this presentation live, so I recorded it in the comfort of my own desk. What you see here are two PCBs extracted from a pump we used to demonstrate how to extract firmware quite some time before. You see the serial via debug interface here. We have those little holders, PCB holders, that can be used to fix the PCB on a magnetic plate, on a magnetic surface. And yeah, it holds very steady, and it's very complicated to operate it with one hand only. The other hand is holding the camera here. So those PCB holders well insulate the PCB from the surface. That means we don't have to risk any electric shocks. We have a connector here on the secondary board, on the secondary PCB. The connector connects to the first one. Let me get this in focus. Yeah, the connector is down here. The pin headers are down here below the PCB. So that's where both PCBs are stacked together in normal operation. Yeah, for debugging and extracting the firmware, we are using those ST links I have shown in the lecture and the seminar already. It's actually an STM32, so an ARM processor used to interface with the PCBs. The PCBs are being connected with some DuPont wires according to the pin out we have seen in the seminar. So everything is connected to the ST link here on a USB port. For the secondary board, we don't have the comfort of an interface like shown. We have a different interface, so we can use either one of those clamps we could order at AliExpress, for instance, for a couple of euro. Or we can use one of those, for instance. There are different options whenever you need to interface with a PCB. In our case, we are using those PC Byte probes that have a little needle at the top, so they can be placed on the PCB. And after doing so, with the help of some goggles, we were able to power on the actual device. So we are feeding the device with some power from or via the serial via debug interface. So let's start OpenOCD. We need to install it here on my computer first. It is important to know where the configuration files, the script files go. We need to give it two parameters actually. One is for the interface, the second configuration file is for the target. So the CPU architecture is important. We need to start another shell here to find where OpenOCD has been installed. Let's go into that directory. I don't think it's the right one, so we might find a link in here. Let's have a look at OpenOCD. Yeah, it's a link to one directory above, Cellar OpenOCD in my case. This depends on your operating system, on your Linux flavor. So we have a share directory here, OpenOCD is in it. We have the scripts directory, and inside the script we will find two directories. One is for the interface and one is for the target. In the target directory we find a lot of pre-configured configuration files. There are some for the K10 CPU. We are using the Freescale CPU on the PCB. You can search the web which configuration file you need. Your AI chatbot will also tell you. We also have a directory for the interfaces. In our case, we need to use an ST-link. If you look at the version 2, you will find out that this one is deprecated. So stlink.cfg is the right one to use. So you start OpenOCD, 2 configuration files are being loaded. Make sure to import the interface first and then the target. So the first parameter is the interface definition, the interface configuration. We are using KLX here. And the second parameter is for the target. Yeah, let's find out where the file is situated. Again, in my case, on a Mac computer, it's lying in this directory. The interface, again, ST-link, configuration, and then the target. Opt, homebrew, and so on. Homebrew is the little helper that installs some GNU tools to my computer. OpenOCD, scripts, target, not interface, target is what we want. And yeah, we can give it a try with KXCFG first, and the output tells us, yeah, there's a different ID required. That's the ID we got from the CPU. So let's go into the right directory and check whether there is a configuration file that contains this ID already. KLX will work, KX will also work after changing the file. So there's a comment just below where I clicked right now. And yeah, now we are connected. And yeah, it tells us we need to connect via Telnet to port 4444. That's what we do in this window here. Localhost 4444. Yeah, do you see the CPU is already halted? I did this before. Usually you can't see the registers when the CPU is running. You have to press halt. I performed a single step operation. You see there is obviously a branch operation here. So it jumped to a different location. The command we want to use now is dump image, which reads from memory, from flash memory, and writes those files or those data to a local file. So if you start dump image without any parameters, it shows you the syntax. The file name is first. Make sure this is a local file name. So in my case, everything needs to go to a certain directory, which I'm looking up right now in a different window. Yeah. Here it is, hopefully. Here, users, THM, download. We could shorten that, but let's do it live. Pump.dump is the file. We start at address 0. We are looking for 32 kilobytes of data. So everything should be dumped right now. Let's have a look into the file. This is the hex dump. Let's look for some characters, or better to have the hex dump beside the characters. And yeah, as you remember, there's a KXX free master string in the pump file. That's everything. Enjoy. See you later. Bye.